Hi everyone, good morning. Can you hear me?
Good morning, sir.
Good
Yeah.
morning.
Good morning. Should we wait for a minute before others join the class? I think only four of us have joined. It's okay. All right. Okay, let's start off with the standard stuff. Let's get into the course material. No more Gyan today. We'll just get on starting with this. I hope it is getting recorded, right? Do we have Kavya on the call? Is Kavya on the call? Hello?
Yes, sir.
Yeah, it is getting recorded? Or do I
Yes, sir.
know that it is getting recorded?
It
Yes.
is getting
Very
recorded,
good.
sir.
All right, let's start off. So, welcome to. Now, can you see my screen? You can't see my screen. I need to share my screen. My screen. Share. All right. I shouldn't simply interface. All right. Okay, so before we start off, once again, we're trying to be data scientists, right? I'm going to just start off the class. Is everybody ready? Quick question.
Yes.
Is
Yes,
everyone
sir.
ready? So, are we all
Yes,
following the rules that we set up in the previous call? Phone in another room, start with a pen and paper, work on the
Yes, sir.
laptop, all of that. Please do that. Okay. So, there is, I mean, you're all adults. I won't be enforcing any of those things, but you will see the difference if you can follow all of those rules. All right. So, since we want to be scientists, what is the one thing that scientists do? What is the one thing that they should do? How does the process of science begin? Who can tell me that? Okay, any engineers in the group? Do we have any engineers in the group?
Yes, sir.
Yes, sir.
All right. So tell me, what is the very first experiment that you did in your engineering physics lab? Very first experiment. So probably in the first week of your engineering
Measurement.
course. What was that? You have to be a little more specific. Can't just say measurement because that's the answer to the question. What is the very first experiment? What did we do? Because it doesn't matter which college you are in the entire planet, everybody will be made to do the same experiment. And it's not just engineering, by the way. Even on if you have taken physics in science, anywhere else, unless you are in the commerce or art streams, you would have done this experiment. Which one
Hello.
is it? Hello.
Sir, it is measurement.
Hmm.
Basically, we have to find the mass, length, and time of a variable.
No, I'm asking for the experiment. You're giving me the concepts. What was the exact thing you were asked to do? You can see the measurement over there. That's why you're saying measurement. What was the exact experiment? And by the way, you don't measure time. I mean, not in the first experiment at all. You don't measure mass either. Both of those things are quite difficult to measure. So you won't be doing it in the very first experiment in engineering first year. Come on. You remember the screw gauge experiment using screw gauge or
Yes,
vernier
sir.
calipers,
Slide caliper, vernier caliper.
right? So remember why we were doing that experiment? And why is it such an important thing in uh, every college, on every course, on every planet? Why are people made to do this measurement? And what did we do in that experiment? Who can tell me what exactly did we do in that experiment? I mean, I understand at that time, we're just 17-year-olds. We don't have a lot of focus. We're more interested in talking to our friends and, just being out, all of that. But still, we still had to do the experiment, right? What were we supposed to do? What was the aim of that experiment? Why does the course start with that experiment? Come on, think fast. I want, back and forth going on. Hello? Guys, come on, please speak up. As I said, be proactive. Use the opportunity to communicate.
So it is basically to measure the diameter of object. Uh,
Diameter, okay, so that would be the vernier caliper, but also sometimes you're given a piece of metal and you're asked to find the length of it. You're given a
yes.
piece of metal and you have to find out what is the length of that thing, right? And what is the procedure? What is the procedure? So you take the screw gauge or the vernier calipers. So vernier calipers are used for getting the diameter of something, say a lug bolt or a nut or something like that.
Yes, sir.
Screw gauges are generally used for finding length. I don't know if I'm mixing them up, but the aim or the aim of the experiment more or less remains the same, right? So you are given a piece of metal, and then you are asked to measure it again and again, not once, right? You are asked to do it again and again. How many times? Roughly 30 times. You're asked to do that roughly 30 times. And at that point, pretty much everybody would be thinking, why am I doing the same thing 30 times? How different is it going to be? And was it different every single time? If you actually did the experiment, you would have gotten measurements such as, let's say, 4.9987, 4.9982, 5.0012, 5.0001, and so on, right? And you would get 30 such 30 such measurements, and then you were supposed to take an average of these things, of these readings. Can somebody tell me, I am not changing the screw gauge, I am not changing the piece of the metal, okay, and the temperature and other things in the laboratory remain more or less the same, why am I getting such varied results? Why am I getting such varied results? Is there something very fundamental to that experiment? Were they trying to make us understand something that is a property of the universe that we live in? Why am I getting such different things? It's the same screw gauge, it is the same vernier caliper, the device remains the same, you are the same, the piece of the metal remains the same, but every time you're measuring it, it is coming out different. Why? Who can tell me the answer?
Because of some environmental effect, noise present in the environment.
Noise, okay. Noise I will allow, but you'll have to be a little more specific. What noise? What exact noise? Anyway, I'll give you the answer. So the answer is that you will never be able to measure anything both with accuracy and precision. These are two words that will keep coming back. I won't go into detail, but if you are going to be very accurate about your measurement, your precision will go off. And in the first place, whenever you're making a measurement, you will never get a perfect number. You will get it a number plus or minus some error. That is called the measurement problem in physics. And that is the point of that experiment. Saying that whenever you're trying to take a measurement, it doesn't matter if it is the length of a piece, if you're trying to measure the time that is taken for somebody to run a particular 100-meter race or anything, there is always going to be some amount of error. You can get your measurement accurate, but then the precision will be off. If you are trying to be very precise, then the accuracy would be off, right? So what is the difference between accuracy and precision? Who can tell me with an example, if possible? Okay, so let's say the time is 8 a.m. Okay, and your clock is showing anywhere between 7:45 and 8:15. Is this accurate or precise? If the actual time is 8 a.m. and your clock is showing anywhere between 7:45 and 8:15, is that accurate or precise?
Precise.
No, this
Precise.
would be accurate because the actual value is lying in between. This would be accurate. This is more accurate. However, let's say the actual time is 8 a.m., but your watch would be showing anywhere between 9:59 and 10:01. Now this is precise, but it is not accurate at all. It is precise because your error is much lower. Here error is high. This is precise but not accurate. If you have a clock which for 8 a.m. is giving a time between 7:45 and 8:15, it is accurate, but it is not precise at all. The variation is very high. The variance or the error is very high. That would be considered accurate. You'll be surprised how many times this accuracy and precision discussion will keep coming back in our discussions. Okay, even when we go to machine learning, even when we go to deep learning, this will keep coming back. What is accuracy? What is precision of the model that we're building? It is something that we need to understand. However, if it is 8 a.m. and it is the error is very low, but it is not accurate at all, then that would be a precise measurement which is not accurate. What if I want something which is, let's say 8 a.m., the same 8 a.m., but I want it between 7:59 and let's say 8:01? This is both accurate and precise. But when you increase accuracy and precision, the cost goes up. When you try to decrease accuracy, when you try to increase accuracy, precision will always go down. When you try to increase precision, the accuracy will go down. And if you try to increase both of them, the cost will go up. Okay, so for example, the same screw gauge experiment or the vernier caliper experiment, right? If I'm using the vernier caliper on this one, if I'm using mechanical one, I will get some amount of variation. If I'm using a laser based measurement device, which is like 10, which like let's say 100 times more expensive, that is going to give me a better precision. So the cost goes up. Now tell me this thing. How is it that we all are absolutely on time, exactly 6:30 a.m.? We all met up on this one particular meeting and we all started on time. How did that happen? How is so that we are all having the perfect time without any precision, any accuracy, problems? We're all able to start on time. You remember, it was not, this is not something that was possible, let's say 20, 30 years back, right? Yes, 20,
Yes,
30
yes,
years back, there was no way people could be on time for a meeting, isn't it?
yes.
Yeah. And we all used to have watches, the winding watches. I used to have one, I remember. In the 90s, I used to have a winding watch. Okay. There was always going to be, I had to ask somebody what is the time and I had to adjust it every once in a while. You remember the reason why your Rolexes and other things are so expensive is because they were both accurate and precise. They could go on for very long. They don't make much sense now, at least from the timekeeping perspective. That is because the clock that we are actually relying on, the internet based clock, it is it is a clock that costs millions of dollars. We're just all sharing that cost, that's all. But the actual cost of keeping time is very high. Where is the time coming from? Who can tell me? Who keeps the world's time? Who tells us that this is 6:30 a.m.? How do we know that there is
It's
6:30 a.m. in India? Hmm?
GMT.
Do we know where the time comes from? How are we managing times for the flights and everything? For the trains? If let's say there are two people who have two different times on tracks, on the train tracks, what will happen? The trains will collide, right? If one
Yes.
station has 8:15 and the other station has 7:30, and they both are on the same track, they will both call each other and they will say, "Yeah, my time is 7:30, your time is 8:15. The trains are on time, but they are on the track at the same time." And they used to collide, and that used to happen a lot, especially in the US. There used to be a lot of train accidents because every town used to have its own time, so there was a need for standardizing the time. Get it? So now do you understand the need for measurement? What scientists do? We need accuracy, we need precision, we need a shared understanding of what exactly we are measuring. Everybody with me so far?
Yes, sir.
Yes, sir.
Yes.
Yes,
Okay.
sir.
So the clock that we are using basically comes from the atomic clock that sits in Greenwich in England. Greenwich, they call it Greenwich in England. So that keeps the entire world's time. We all share that time. So that is called the Greenwich Mean Time. So that is the 00, and we are 5.5 hours over it. So the timekeeping in India comes from there. So ever since we had internet, we basically are using the same time and we're kind of putting it across all of our devices. So all the time that we're looking at is kind of related to the atomic clock over there. So that atomic clock is worth hundreds of millions of dollars. So that is what we are using, right? Okay, so that is where the measurement comes from. So the point of measurement is the reason why the vernier caliper was not giving the same thing is you will never be able to get exact measurement of anything. There is always going to be some amount of variance or variation depending upon how you are interpreting it. There is going to be some amount of variance or variation. Measurement is the most basic thing. Anything that you want to understand, you have to be able to measure it. If you cannot measure it, then it is not scientific. It is not something that falls into the purview of science. If you cannot measure it, you cannot improve it. Okay, please write that down. If you cannot measure it, you cannot improve it. If you cannot measure it, you cannot improve it. So, for example, if I want to lose weight, I have to first be able to measure what my current weight is. And I have to do some exercise or some diet, and then I have to measure my weight again. If I have to improve on a particular metric, I have to be able to measure it, right? If I am taking certain time to kind of finish a particular task and I want to be faster at that task, I want to play my piano faster, I want to play my guitar faster, I have to be able to put up a time and I have to measure it, right? If I'm trying to run, let's say 20 meters, 30 meters, I want to be able to measure those things. If you can't measure it, you cannot improve it. That is the basic premise of science. And the idea is whatever the metric that we are working with, remember our discussion on metrics? Whatever is the metric that you are trying to understand, you have to be able to understand the importance of that metric and you have to be able to measure it. You first measure it, then you do something, and then you see the change in that metrics measurement, and then you understand whether whatever you're doing it is helping it or not helping it. So that is the very first point. So in order to start making measurements, we have to understand what is a variable. What is a variable? What is the opposite of a variable? Come on, first. What is variable? What is the opposite of a variable? Why do we need variables? Hello? Yeah, please go
Variable is
ahead.
the attribute which can be changed,
Variable is a
which attribute
attribute. Okay, ठीक है.
that can vary.
That can vary. Can you give me an example?
Mm,
Let's say height of people, it varies.
yes, yes.
Weight of people, simple things. Okay. height, weight, let's say blood sugar levels, cholesterol levels. If I want to look in terms of anything else, the speed with which you are running, all of those things are going to constantly change. Basically, everything that we are trying to measure is basically a variable. What is the opposite of a variable?
Constant.
It will be a constant. So the constant does not change in time. So the characteristics of an abstract quantity that allows it to take more than one variable. Anytime there is something that you're measuring which will take more than one value, that is called a variable. And variables vary. That's the whole point of it. The opposite of variable is a constant. So variables are what are measured, constants are not. You do not measure constants. Speed of light is a constant. You do not measure it. Variables are what we get measured. They quantify and document the properties of a attribute. Let's use your term attribute that we are interested in measuring. Okay, so the variable must have all the possible levels. So for example, the word level, we have to understand this better because that is something that keeps coming up. Let's say I'm trying to measure gender. Okay, my boss kind of put me at the beginning of a mall and he wanted to understand how many men and how many women come into the mall on a daily basis. Right? So I am standing there and I'm kind of taking how many men came by, how many women came by. How many levels does it take? It takes, let's say, 3 levels: men, women, others. Right? So men and women would be more or less, let's say, out of 100 people, you would have, let's say, 49, you have 50, and let's say 1. Right? So others would be relatively less in the frequency. So this gender is taking 3 levels. So it is a categorical variable. This is a categorical variable and it is taking 3 levels. Make sense? Let's say I am trying to get cities. Cities is one of the variables in my Excel sheet. Then I would have, let's say, Hyderabad, Bangalore, Baroda, and so on. So these are 3 levels. If there are 5 cities, then it will be 5 levels. Make sense? Yes? So now, let's say I am trying to measure temperature. Okay? Now temperature, I'm, let's say, taking at 96 degrees, 97 degrees, 98 degrees, and so on. There are no points or something. Then it is taking, let's say, 10 or 100 different levels. If I'm including all the values in between, how many levels would it be? Something like temperature, something like height, something like weight, right? Something like the amount of water in terms of liters or something. That would be infinite levels. So different variables have different levels, right? So the variable must be exhaustive. It should include all positive values or all the possible values that it can take. And it also should be mutually exclusive. For example, if a person has been measured as M, they cannot be W or O. If a person has been measured as W, then they cannot be O or M. Yes? So your variables must be mutually exclusive and exhaustive. This is a very important property for any variable. Mutually exclusive and exhaustive. Please write this down because this also comes up a little later. When we try to do probability, mutually exclusive and exhaustive is something that we need to understand. So if I'm taking a set of all the possible outcomes, please write that down. If I'm taking a set of all the possible outcomes, then that set must be exhaustive. It must also be mutually exclusive. Let me give you an example of that. Let's say I'm trying to look at the outcomes of every delivery in a cricket match. Each delivery, what are the possible outcomes? What are the various things that can happen after a bowler has bowled? I hope everybody understands cricket here, right?
Yes.
Basics of cricket.
There may be 6, 4.
We'll start with the basic one. What is the first thing? It can be a dot ball. Or
Broad one.
Single.
1
Or
or 2, 3. It can be a 4. There is an occasional 5. There is
Yeah.
an occasional 5 runs given, right? Or a 6. What else can happen?
No ball.
There could be a no ball. There could
Wow.
be a wide.
Wicket.
There could be a dead ball. Yeah, are there any other options?
So it may be a wicket also.
It can be
Wicket
a
also.
wicket also. Very good. What else? Is there anything that can happen in a particular ball? Just the outcome. So let's say these are the possible outcomes. We don't really need to know everything. Let's say these are the possible outcomes. Can I then say, this set is exhaustive? Yes. I can then say that this set is exhaustive, right? It contains all the possible outcomes. Then, if 2 runs have been scored, it means that none of the other things have been done. Yes. If 2 runs were scored off the bat, then it wasn't a no ball, it wasn't a wide, it wasn't a 0 or a 1 or so and so. Let's not get into technicalities, but can we assume that if 1 has happened, the others have not happened. If it was a 6, it is not a 4. If it was a wicket, it was none of these things. Yes.
Yeah.
Yes.
So that is the definition of what is called exhaustive and mutually exclusive. So whenever you're taking a measurement, it must follow these properties. If it is not mutually exclusive, and if 6 can happen, then 4 also could have happened on the same proper delivery, then it is not a measurement. If 2 things are happening at the same time, then it is not a measurement. That is also the reason when we have an Excel sheet, right? When we have an Excel sheet, a value can only take up one thing, isn't it? A cell can only take up one value. It is not taking up 2 different values, isn't it?
Yes.
Yeah.
Yes, sir.
So that is the reason why a data entry or a measurement of a particular variable has to be mutually exclusive and it has to be exhaustive. Any questions on this? Okay, so anyway, measurement, it is the act of quantifying a phenomena. So whatever you're doing, you have to quantify it. You're trying to measure it. You're trying to give it a number. A number, it can be just a value. Blue, green, yellow is also a measurement. So we'll kind of get into it just in a second. Assigning numbers or values to represent the various levels that the variable can take. You see, the levels basically are the various values it can take. When you are trying to measure the piece of metal using vernier calipers, it was able to take a large number of values. It has many levels. If you're trying to measure the gender, if you're trying to measure a city, it can only take a few values. Those are called the number of levels. So measurement is the outcome of an experiment. Measurements are observations. Observations, measurements basically are interchangeable. So what are the types of data? So types of data is whenever I'm trying measurement, I will get data. When you are doing the vernier caliper experiment, you are supposed to take 30 readings. 30 readings and then take an average. The problem is nobody really explains why you are doing that experiment. That is a little sad because the lab assistants who are there to make you do the experiments, either they don't care or they never had the right training, but that was supposed to be one of the most important experiments, right? Because you take the learnings from that experiment and you apply it everywhere else. Later when you go to the chemistry lab, you are doing the titrations 5 times, 6 times, 10 times. So you need to understand why it is important to do it 30 times. It is not possible to do everything 30 times, but you need to understand why we were doing it 30 times, because that number kind of gets you a pretty good understanding of the variation in your data set. Okay, so that is the reason why that experiment happens at the beginning of every professional career. It is at the very beginning. So they are trying to make you understand that you are not going to get the correct answer just by doing a measurement once. You have to repeat the experiment to understand how many different values a particular phenomena is taking. Is that clear, everybody? It might sound a
Yes, sir.
little boring, but these are all important because you need to understand what a measurement is. It is very important to understand why we take multiple things, and that is the reason why averages or medians or everything else exist, right? So that brings us, whenever we are trying to take multiple measurements, we are going to be coming up with what is called a data. A data is basically a collection of raw facts and figures. Okay, it is just raw facts and figures. Data by itself does not contain anything. You have to kind of put it in context to understand. So the various types of data, not to be confused with data types. So always write it down as types of data, because data types are something that we discuss in Python programming. Okay, data types are different. They are related, but they are different. Types of data are, these are referred to as levels of measurement. The first part is nominal. Nominal refers to as name only. There are certain type of things which only can have a name, like gender. For example, here we can do gender. The second part is called ordinal. Ordinal basically means ordered. Here we get rank and rating. Okay, so it is like, is first rank greater than second rank? Is first rank greater than second rank? Yes,
Yes.
right?
Yes.
But is the difference between first rank and second rank the same as second and third? Let's say first rank was 97.5%. Second rank was 78%. Third rank was 77.9%. The distance between first and second is not the same as the distance between second and third, right? Yet 1 is
Yes,
greater
sir.
than 2 is greater than 3. The order is very clear. We have ordinal data. Similarly, rating. On a scale of 0 to 10, how satisfied are you with Air India Express? Those guys delayed my flight on Friday by 8 hours. So I was basically on the road for 8 hours. They said it was supposed to be 8 o'clock. It went on to like 3 a.m. 8 p.m. I was supposed to be going. I was just roaming around till 3 a.m. So how satisfied I am with Air India Express? On a scale of 0 to 10, I am zero satisfied. Yes. Let's say everything was perfect. They even upgraded me to first class or something like that. And let's say I got the perfect uh, travel experience. I would say I am at a 9 or a 10. Okay. Is 9, the difference between 9 and 10, the same as the difference between, let's say, 6 and 7? If somebody gives you a rating of 9 or 10, that is recently pretty good, right? But the difference between 7 and 6 could be very, very large. In fact, we have something known as NPS. How many of you know NPS? How many of you know NPS? Have any of you heard of this term, NPS, Net Promoter Score? Net Promoter Score. Have you heard of it?
Yeah, it's a measure for the customer loyalty.
It is a measurement for customer loyalty. Where was it first implemented? Which company invented it? Do you know that?
No, sir.
Yeah, it was invented by Bain and Company, but it was first implemented in Motorola, and then it was exclusively implemented in GE. So I was in GE around the time it was beginning to be implemented. So GE kind of took the Net Promoter Score very, very seriously. And even to this day, even in my company currently also, we kind of track Net Promoter Scores, as in your basically satisfaction / loyalty scores. So what does the Net Promoter Score actually say? It is a very highly tried and tested measure. Okay, so every company of GE always relies on the Net Promoter Score to kind of improve their performances, their service deliveries, and other things. So you might even have seen Net Promoter Score from HDFC Bank and those kind of places also. Net Promoter Score basically says that if you are if you are giving a 9 or a 10, then you are what is known as a promoter. A promoter is somebody who will actively recommend your business to a friend or a colleague. Okay, so I'm also trying to explain you where ordinal data and these kind of things actually apply. How do you use that to improve businesses? Okay, please write down Net Promoter Score and also go back and do some research on Net Promoter Score, because knowing NPS is a very important job skill. Okay, everybody in the class, please write down Net Promoter Score, whatever I'm saying. Also, go back, go on YouTube and watch at least 1 or 2 videos about Net Promoter Score, how it is implemented, how it is used in industry. Okay, because one of my jobs back in when I was with HP was to just analyze NPS scores for a whole bunch of people. Okay, basically deliver our vendors Net Promoter Scores. I was just creating reports on top of that. So that is a job skill. So if somebody is giving me a 9 or a 10, they are called promoters. In fact, the question that we ask is, on a scale of 1 to 10, how likely are you to recommend us to a friend or a colleague? That is the question. It is not how satisfied are you with our service. The question is, how likely are you to recommend us to a friend or a colleague? So if it is saying 9 or 10, then they are promoters, which means that they are likely to actually go ahead and recommend our product or service to a friend or a colleague. If they are 7 to 8, they are called passively satisfied customers, passives. If anything less than 7, they are called detractors, which means not only they are not going to come back to us, they are going to go ahead and tell other people, don't buy this product. They will reduce your business. So this part should be 0. This part should be improved. These are your promoters. Okay, so NPS is given as percentage promoters minus percentage detractors. Okay, now Net Promoter Score is not an absolute thing. You have to take your Net Promoter Score and compare it with the Net Promoter Score for your competitors. That is when you get where you are, because there is no perfect NPS score. It can be 100%, it can be minus 25%. Either way, you will not be able to say whether your NPS score is good or not. But you can see the improvement in your Net Promoter Score, right? So this is what I'm measuring. This is my Net Promoter Score this year. What is my Net Promoter Score next year? Has it increased or has it decreased? That is how I would know whether my customer loyalty has increased or decreased. Does everybody follow this?
Yes, sir.
So the point is, the difference between 9 and let's say 8 is big. 9 and 10 is not big. Anything less than 7 is very, very big. These people are not going to harm you, but these people are going to harm you a lot. Right? So that is where your have you taken down all of this? Can I erase it? Can I erase
Yes,
it?
sir.
Yeah.
Yes, sir.
Okay, so ordinal data is basically your rating and ranking. The difference between the two levels may not be the same, but they definitely have an order. 9 is definitely greater than 7, but the difference between 9 and 8 is not the same as the difference between 8 and 7. Then you have interval scale. Interval scale is when we do not have a standard 0. 0 doesn't exist. 0 is arbitrary. Your 0 is arbitrary. So the measurement, the what you call 0 is not clearly obvious to people. And of course, when it comes to ratio, it is any numerical data that becomes ratio. Let's take a look at it in a little more detail. Nominal variables are basically nominal or for the sake of name. Okay? So the only property that they contain is a name, nothing else, like gender. So gender is the best example to give, gender or city names or anything else. Numbers, if used, are simply codes for the real. So, for example, if I'm taking M, women, and O, and I'm calling it 0, 1, 2, They are just codes. Doesn't mean that 0 is less than 1 or 1 is less than 2 or anything like that. Okay, in fact, you should not be doing this. We will also talk about how to give numerical values to categorical variables. Okay, so for example, if I have three variables, right, three levels, I will do something like this. So for example, um, I have this data, serial number 1, 2, 3, and I have gender, okay, M, W, O. I should, if I translate this data set into something like this, serial number 1, 2, 3, and gender 0, 1, 2, this is wrong. This is wrong. This is the way I'm converting NW into 0, 1, 2. This would be wrong. The way we do it is kind of like this. I have serial number. I have gender 1, gender 2, gender 3. What would I do? Serial number 1, 2, 3. I will take M and I will do this 1, 0, 0. 2, 0, 1, 0. 3, 0, 0, 2. If it is 1, 0, 0, it is M. If it is 0, 1, 0, it is W. 0, 0, 1, it is O. This is called one-hot encoding. This is the only way you should convert your categorical variables into data. Everybody follows this? Don't worry if you don't get it, because we will come to it when we come to machine learning. But the idea is, this is wrong, this is correct. Any questions here? I can also kind of write it like this. Serial number 1, 2, 3. Instead of having 3 of them, I will just do G1, G2. Okay? 1 and 0 is M. 0 and 1 is W. 0, 0 is O. This is also okay. This is called the dummy variables concept. If G1 is 1 and G2 is 0, then it is a man. If G1 is 0 and G2 is 1, then it is a woman. If both are 0, they are neither men nor women. That is the idea. Do you want me to repeat this? And why do we have to do this? Tell me. Why can't I just go ahead with MWO? Why do I have to convert that into numbers?
Machine learning won't understand the human language.
Exactly. Right? Because if I'm writing MWO, it doesn't make any sense for the computer. So computer can only understand yes or no, binary, numbers. It can understand quantities, it can calculate distances, it can calculate averages, those kind of things. But MW will not have any direct meaning for itself. Okay, so that is the reason why we convert something like this into this, so that we can kind of do other calculations on top of this. Did you kind of write it down? Just write down these things: one hot encoding, dummy variables. Okay, if you can go ahead and research it, or you can ask me. I will explain it to you again. All right. We're also going to take a look at how to convert these values into these things a little later, not right now. Any questions here? All right. So nominal, for the sake of name only, they simply use codes, gender, city, country names, names of rivers, brands of mobile phones, PC, Macs, Linux, and any of these things are basically just nominal. So depending upon the number of levels, each one of these things, for example, what kind of PC, what kind of computer do you own? It is PC or Mac or Linux, right? Then you have 3 levels. What kind of phone do you own? iOS or Android or Nokia? Push phone. So you have 3 levels. So one of the ways we do data analysis is by we take iOS, Android, and let's say there are 15 other categories. We put all of them into others. It is an easier way of managing data. Any questions?
No, sir.
Okay, so that is one of the ways we kind of go ahead. So, for example, iOS, Android will account for like 98% of all the phones. The others will account for 2%. It is not the most important, but they have 15 different variables. I don't want that many levels, so I will just put all of them into others, or I will just drop all of those values because that is not useful for my analysis. Then ordinal variables, we've talked about it. Nominal, they have a magnitude and an order. We know the relative order, but we do not know the difference. We do not know the difference. So, for example, A minus B will not make any sense. Here also, even in nominal variables, addition subtraction won't make any sense, right? Right? I cannot say men greater than women or women greater than men. That won't make any sense. I cannot say iOS greater than Android. Right?
Yes, sir.
Those are things that they're just not equal. The only thing that I can say is iOS equal to Android or not equal to Android. I can only say equal to, not equal to. Okay. Again, we're not talking here about feelings because feelings cannot be quantified. Only if you can quantify your feeling, only then it becomes a real thing. Okay. Sure, you can. For example, I can say, I'm angry, I'm very angry. Those are relative, right? So that becomes an ordinal variable. Yes, I'm angry, I'm very angry. They're definitely relative, but how much more angry, I cannot say. There is no measurement for the amount of anger. Yes. So again, comes back to the point that if we are not able to measure it, it is not something that you can improve upon it. All right. Interval variables. So interval variables are a little interesting because the main thing is the distance between A and B and the distance between B and C is the same. Okay, so this here is where a very good interview question comes by. I want you to kind of understand it very well. Okay, whenever let's assume that you get a question which says, give me an example of an interval variable. Pretty much everyone out there, including people who have a lot of experience, will basically say temperature. Okay, and it is a perfectly good example because every textbook gives you the same example, temperature. Why temperature? Because temperature, there is degrees Celsius, there is degrees Fahrenheit. The 0 of degrees Celsius and 0 of degrees Fahrenheit is not the same. Yes, but the difference between 25 degrees and 30 degrees Celsius is the same as the difference between 30 degrees and 35 degrees Celsius. Yes. But
Yes.
you can also say, can I say, for example, if it is 50 degrees Celsius, can I say it is twice as hot as 25 degrees Celsius? Can I say 50 degrees Celsius is twice as hot as 25 degrees Celsius?
Yes.
You cannot. 25 degrees Celsius is very pleasant. 50 degrees Celsius is, borderline boiling. You will not be able to survive for, more than a couple of hours at 50 degrees Celsius. Maybe 6 hours, 7 hours, but at the end, you will definitely go unconscious. It is not twice as hot, it's much, much hotter. And the reason why it is also not correct is, for example, here you can definitely say the temperature is 25 degrees higher. That is perfectly good to say. The temperature increased by 25 degrees Celsius is perfectly okay to say, but you cannot say twice as hot. You cannot say twice as hot. Because how is temperature measured? How is 1 degree Celsius measured? Engineers, come on. Thermodynamics. What is the definition of 1 degree Celsius? Okay. So let's say you have ice at 0 degrees Celsius. You are giving it some amount of heat. you give it some amount of heat and the temperature goes from 0 to 1. The amount of heat taken to increase the temperature of water by 1 degree Celsius, that remains the same. Make sense? It is the amount of energy taken to increase the temperature of water from 0 to 1. That is the heat that we are looking at. So that part is fine. But the 0 degree Celsius is arbitrary. Somebody decided that the point at which the ice is melting, we will call that 0, and rest of it, we will base it on the basis of that. Right? So imagine if I'm saying the speed of my car is 0. What do you understand? If I'm saying that the speed of my car is 0, what do you understand? Come on.
This means this is an ideal position.
It's a idle position. It is not moving. Nobody will understand anything differently, right? There is no ambiguity. But if I'm saying 0 degrees, the temperature is 0 degrees, you are still waiting to find out whether it is Kelvin, whether it is what do you call, Fahrenheit or degree Celsius, right? That is the question you're waiting to see, isn't it? So when the 0 is not set, okay, it is not the same for everybody, then it becomes an issue. That is why the interval becomes. So this is something that everybody will say. So this is the answer everybody gives. What is the example of an interval variable? Then you say temperature and you give all of this. This is what everybody does. However, I want us to do something different. So we do talk about temperature, we do talk about how the 0 is arbitrary, okay, all of that standard stuff. But let's say I'm measuring heights of certain students, male students in class 8, okay. I have 120 centimeters, 125, 128, 122, 121, 122, 143, 128, 130, 140, 125, 132, 135, and so on. I would now like to convert this into an interval scale. I will say 120 to 125, 125 to 130, 130 to 135, 135 to 140, 140 to 145. And I will get frequencies over here. 120 to 125, how many do I have? 1, 2, 3, 4, 5, 6. I have 6 of them. 125 to 130, 1, 2, I have 2 of them. 130 to 135, 1, 2, 3. I have 3 of them. 135 to 140, is there a 138 somewhere? 128, 138. Let's say 0. 140 to 145, I have 1, 2. Is that all? I have 2 of them. This is also an interval scale. If I'm taking some data and I am converting them into intervals, that is also called an interval scale. Everybody with me so far?
Yes, sir.
So while everybody else says temperature and they are stuck, we will also give this additional example. Okay, that shows us that we have actually done a little more work compared to everybody else. Trust me, Literally nobody says this in any interview. I have been waiting for somebody to tell me that yes, interval scale is temperature, that is cool, everybody knows that, but this also is interval scale. This is a way of converting very large amounts of data into understandable formats. Because for me, it is really not that important to understand what is the exact height of the students. I want intervals, right? So it is not the difference. The difference between 122 and 121 centimeters of height is really not that different for me. The difference is big for 120 and 140 because in the same class there is a 20 centimeter difference. 20 centimeters is almost a foot and a half, isn't it? That difference is very important to me. 1 centimeter difference, I'm okay with it. That amount of variation is fine among children. But if there is a foot and a half difference, then I need to know why. Are they the same age? Because at 8th standard, right, you're just around the place where your bodies are changing, especially for boys, right? So they hit puberty a little late. I need to understand how they are growing. They have growth spurts around that time. They need to get a lot more protein. They start eating a lot more, right? At the 8th standard, 9th standard is when their voice also starts cracking. They start becoming men around that time. So the difference between 120 and 140 is much more important to me. Why are certain kids at 140 and why are the others at 120? Is it because of a lack in their diet or something like that? That is more important to me. What can I do to improve it? Maybe I should increase the little more protein, or I should make them run a little more so that they can hit that higher height faster. Or maybe it's just a genetic thing and there is nothing I can do about it, right? So that is how we should be using data. So the whole point of doing data analysis is to be able to understand what problems I can solve. So it should always start from what problems I can solve. Let me go collect the data and then let me analyze the data. But on the other hand, what happens? We are always given a data and say analyze it. I have no idea what I'm looking at, why I'm doing it, and we never ask the questions. That is an important part. Is everybody with me so far?
Yes, sir.
Hello?
Yes. Yes, sir.
Any questions on this?
So, can you consider data as an interval data?
Yes, date is an interval. Absolutely perfect. Because I can get the difference between two dates. I can get the difference between two dates, but I cannot multiply. So, for example, I can tell the difference between May 18, 1982, that is my birthday, and let's say today's thing, whatever it is. Today is what? June 19, 2024. I can tell the difference in terms of days, but I cannot divide June 24 by May 18, right? That would not make any sense. Yes or no?
Yes.
I cannot do multiplication or division. I can do definitely addition, subtraction. Yes or no? In fact, you can do that in Excel also. In Excel also, you can kind of get the difference. So date is another thing. So if we get the question in an interview, we're going to use date and we're going to use the interval scale in addition to the temperature. So what happens is when you do those kind of things, the interviewer will stop asking you stupid questions like these things. These are all very basic questions. He will jump to tougher questions. And if we do well in those tougher questions, then we make a much bigger impression. Our probabilities of cracking the interview actually go up. Does that make sense? It is like your GMAT question, right? GMAT question paper. What happens in GMAT or GRE, SAT, all of these kind of exams? How do they work? Have any of you taken GMAT, GRE? They are your computer adaptive tests, CATs. Okay, so what happens is your first question is an average, toughness question. If you do it well, you get a tougher question. If you do that well, you get an even tougher question. Tough questions carry more marks. If you're getting that wrong, you'll get an easier question. So basically, they are trying to assess where your overall level is. The more tough questions you get, the better your score is going to be. You take the first 5-10 questions which are wrong, then your score goes down and it gets quite difficult for you to kind of go back up. It is not just a score, it is about also the kind of questions that you're asking. So the same happens in an interview. They start with a very basic question. If we give very good answers to it, they quickly go to the tough questions. They will then start looking at your CV. They will start looking at your projects. Then they will ask other questions about your inclusion, your team skills, and other things, communication skills, everything else. That is where you shine. So these are the ways of assessing where your actual ability lies. If we are giving standard answers to these things, they will go through few more questions. After that, they will not going to notice because they are taking so many more interviews. They will just ignore it and you will be forgotten. So that is not something that we have to do. We have to we have to make our mark ahead in the interview, right in the very first time. Okay, so we'll talk about those things. So that is interview, current age, temperature, height, all of these things become intervals. We also can add a date to it. Thank you very much. I will add that. We can also add a date as an interval variable. Time interval is an interval. Any questions on this? And everything else, all the other numerical variables basically are your ratio variables. Okay, so from here on, sorry, I was about to fall. Okay, so from here on, whenever I say distribution, right, please understand it as a frequency distribution. Because we will also come across something known as a probability distribution later on. So if I don't say probability distribution, understand it as a frequency distribution. Okay, a frequency distribution is simply a chart that we make for the various levels and how many times it shows up. Simple. A frequency distribution is a chart of my levels on the x-axis and how many times does it show up, the frequency, on the y-axis. Yes, so distribution is a measurement of how a particular variable is spread across the levels. So the distribution across the various levels is called a frequency distribution. Some levels are achieved more often, some are not. Right? So for example, if I am, let's say, looking at our cricket example, I'll have, let's say, dot balls, I will have fours, I will have, let's say, sixes. Dot balls will occur more often. My mind still works in terms of ODI cricket, so dot balls are more frequent. Then I have more fours, then I have a few sixes. Let's say the same thing comes to this thing. I will still have T20 cricket. Let's say there will still be more dot balls. Okay, maybe there are less fours, but there are more sixes. Yes. So this is the various levels, and this is the frequency. Any questions here? So why do we need distributions? Why do we need distributions? Hello? Guys, are you there? I'm not getting enough feedback from you. Is everybody there?
Yes,
Yes,
sir.
sir.
Yes,
Yeah.
sir.
So please feel free to talk. In the next 6 months, I want you to be able to freely talk about anything. Okay? I mean, you don't have to share your personal details or other things with me, but if you are in a meeting, I want you to be able to have original opinions and be able to talk. That is a skill that, for some reason among Indians, it is just beaten down. We're asked to kind of shut up, listen, or shut up and just stay there, sit there. That is something that becomes a part of us. You know? So I want you to have an opinion. I want you to be able to articulate it. Over time, we will get better. But if you don't try, you're not going to get better. All right? It is okay to give wrong answers. No judgment here. None of us are, impeccable. But I want you to articulate. Especially people who have trouble communicating, I want you to start doing it more. There won't be any judgment in the class. All right? We have 6 months. We want to improve those skills. Anything. For example, if your interviewer asks you, do you have any more questions? You should have more questions. A lot of us say no, sir, and then we just leave. Yes or no?
Yes,
Yes.
sir.
We should use every opportunity that we get to kind of make a dent. We have to make an impression. Okay, ask simple questions like, what do you do for fun here? Do you have a cricket team? Do you have a basketball court? Is there a table tennis table? Right? Yes or no?
Yeah.
Yes.
Okay, so we also need to, for example, you won't ask something like, when will you send me on site or something like that. Those are intrusive questions. Ask simple questions. Do you have a cricket team? I like to play cricket. That is a fun question to ask, isn't it? So even when you're leaving, you're kind of making an impression on the guy. Yes or no? All right. So why do we need distributions? Why do we need a pictorial representation of any data?
It provides insight into the characteristic and behavioral data.
It provides insight. More importantly, it helps us visualize because we are visual thinkers. We understand a visual data better than just a list of numbers. Okay. Since humans are visual creatures, it makes more sense to kind of show a picture rather than whole bunch of words. A picture is worth 1,000 words, right? So we give one picture instead of 1,000 numbers. That is one of the main things. So whenever I'm saying distribution, please remember I would be referring to a frequency distribution. A frequency distribution. Because later on we will also come across what is known as a probability distribution. All right. So take a look at this one. So what are the things that we can do with these various data types? Nominal. We can do equality, not equality. Okay. We can do equal, not equal. Only. There is nothing else we can do about it. What can we do? We can only do counts. So if I have a nominal variable, I have nominal, or it also sometimes is called a categorical variable. Categorical. This is also sometimes called categorical. Okay. Also known as discrete. Discrete. So these are the various names we can give. Nominal, categorical, discrete. So both nominal and ordinal are categorical / discrete data types. Okay, they have equality. They only do counts and measures of central tendency. We'll come to what a measure of central tendency is. The thing that we can only do is mode. Mode is basically the number of counts of each of the variables, each of the levels. There is no measure of variability. I cannot measure any variance of these things. How do I do a data visualization? I can do frequency tables and charts. Basically, I can only do a bar graph here. Yes? For nominal variables, I can only do mathematical operation which is equal to, not equal to. iOS is equal to or not equal to Android. That's it. Ordinal, I can also do comparisons. I can do greater than, less than. However, I cannot tell the difference in the various things. So rank and rating, right? I cannot tell how different that thing is. So I can arrange them in increasing and decreasing or count. I can also count these variables. So I can do definitely, I can do mode. I can also do median. For example, I can ask how many people gave us a rating of 9? How many people gave us a rating of 10? How many of us are, how many of the values are detractors? Right? Yes, now. So here also data visualization is frequency tables and charts. Yes.
Yeah.
Then when it comes to interval, I can do all of those things except multiplication and division. Remember, 50 degrees Celsius is not twice as hot as 25 degrees Celsius. Also, 25 degrees Celsius is not infinitely hotter than 0 degrees Celsius, right? If we go by the same logic, 25 degrees Celsius is not infinitely hotter than 0 degrees Celsius. It is just 25 degrees hotter, that's all. Right? You cannot do multiplication division. That is because there is no zero. Zero is arbitrary. It is not a mathematical certainty. Okay? So that's where we get mode median. We can also calculate an arithmetic mean. What is an arithmetic mean? What is an arithmetic mean?
Average.
Average.
Average. How is it given? How is it denoted? Sigma I runs from 1 to n, xi divided by n. We'll come to the mathematical representation in some time. Okay, so the average is basically a sum of all of the values divided by the number of observations. Okay, it is a summation of all the observations divided by the number of observations. So that is an arithmetic mean. Range, interquartile range, standard deviation, variance, all of these things can be calculated. What are these things? We will come to it in just some time. What are the kind of visualization I can do? Frequency tables, charts. I can also do pie charts. I can do line charts. I can do box plots, anything. What are each one of these visualizations? Those are also things that we will cover on either today or we'll cover it on Friday. Then ratio is basically numerical data. You also need to understand that as we go down this chart, there is more information that is getting collected. The quality of the information is higher. Okay. Now, nominal cannot be converted to ratio, but ratio can be converted to nominal. How can I do that? How would I convert a ratio variable to a nominal variable? Yes? How would I convert a ratio variable to a nominal variable? Okay. Let's say I have salaries of people. So there is like 30K, 45K, 50K, and so on. Can I not convert these things into 20 to 25K? 25 to 30K? 25 to 50K? Greater than 50K? And so on? Now you may say this is interval. So let me ask you one question. What about it is less than 50K, greater than 50K? Then that just becomes two categories, right?
Yes.
So I can take my ratio variable, I can basically convert that into categories. Sometimes that is easier. Because for me, the difference between 25K and 28K is not much. But I need to know if it is less than 50K or greater than 50K. That is more important to me. So depending upon the situation, I can convert a ratio scale to a categorical scale. And we do that often, by the way. Okay? I can take a continuous value and make it discrete, but I cannot take a discrete value and make it continuous. I can treat it as a continuous. I can take ordinal and treat it as a continuous, but then it might give me some errors. So as I'm going down, this cannot become this, but this can become this. I can take an interval scale and treat it as ordinal. I can treat it as categorical. But the opposite will not be true. Yes?
Sir, how come that salary range will be categorized into a ratio, sir?
Which one?
How come that means the salary intervals, right? It will be um, specify as an interval, right? 20 to 25 or 25 to 30K.
Yeah. But then if I'm saying greater than 50K, not all the intervals are same. Not all the intervals are same, right?
Yeah.
Yeah. Again, it depends upon how you're treating the data. If I'm treating it as just categories, are you less than 30K, 30 to 50K, 50K and greater? That is one way of categorizing. Because for me, the difference between the say, let's say 30 to 50 is not that much. The person who is making 32K is the same as somebody who is making 48K. For that particular purpose that I'm doing, I don't make any distinction. I need to know under 30K, 30 to 50K, greater than 50K. That is of more importance to me. Yes?
Yeah, yes, sir.
So yeah, what you're saying is true, but the opposite will not be true. For example, what is an interval scale cannot become a ratio scale. A ratio can be converted to an interval, it can be converted to ordinal, it can be converted to nominal. The opposite will not be true because the information required is not there to make it a ratio scale. Get it?
Okay, sir.
Okay. So whatever is ratio can be converted into something smaller, something lesser than that. But I cannot take a nominal and I cannot do it. So for example, it is like this. Um, I have a name. Okay, I have a name Mark. Okay, and I have another name. Let's say Steve. I cannot say Mark plus Steve, right? I cannot do Mark plus Steve. I can basically only say Mark is equal to Steve or Mark is not equal to Steve. That's it. There is nothing I can do about adding Mark and Steve. Yes?
Yes, sir.
Yes.
On the other hand, let's say I have 35 and I have 45. I can do addition, subtraction, multiplication, division, and everything, or I can just convert them into strings. 35 is just a name. That's it. What is your name? My name is 35. It is a little weird, but it is not wrong. Get it? So, for example, my house number is 35. That becomes a name, right? I live in apartment number 35. That just becomes a name. It doesn't mean anything. Apartment number 35 is not greater than apartment number 34, isn't it? They're just different. So, numbers can become names, but names cannot become numbers. That's what I'm trying to say. Any questions? Hello?
No, sir.
No, sir.
So that is where we are. So what are the measures? So there are basically two ways of measuring. One is called a measure of central tendency. One is called a measure of central tendency. So one thing that you need to understand about statistics is that when most of the names directly mean exactly what they mean, there is no cleverness in the naming of things. So if I'm saying measure of central tendency, I'm basically trying to measure where the center is tending to fall. There is almost never any cleverness or any chalugiri going on over there to the names. Almost always in statistics, they mean exactly what they mean. That kind of makes things easier. Also a little boring, but that makes definitely things a little easier. Okay. So while a lot of textbooks for some reason talk about skewness and peakedness, I have literally never used it nor seen it, but I can give you the formula for it. I have never seen it being applied anywhere. On the other hand, your center and spread are applied all the time. Okay. So the main thing that we want to understand is in a particular distribution, if I have a frequency distribution, where is the center falling? Where is the center? Where is the center tending to fall? And can I measure it? And I want to look at the spread. Where is the center? How much is the spread? That usually gives me a very good understanding of the properties of the data that I am using. Any questions here?
No, sir.
Okay. So when it comes to the center, measure of central tendency, I have three measures. I have a mode, median, and mean. Who can tell me the difference between median and mean? How is mean calculated?
First, we have to sort it.
Sort it.
Then we have depend on which out whether we have to take consider the total count of that one.
Hmm.
Then based on like even if it's a even or odd, based on that one we have to
Okay, so
consider.
basically middle value. So
Yeah.
sort it and find the middle value. Okay. If it is even, then you have to get the average of the middle two values. So basically, we're trying to get a point where the middle value is going to be. Okay, so the idea is that median and mean are two things which can give us a better sense of where the center is actually lying. Sometimes when you have outliers, median is a more reliable, and other times mean is a more reliable thing. If the distribution is uniform, then mean becomes more reliable. If it is not a uniform distribution, then we can go for median. If it is categorical, then we simply go with mode. If it is a categorical variable, then it simply goes with mode. Yes. On the other hand, spreads have a whole bunch of values. So, for example, I can start with simple range. What is the maximum minus what is the minimum? Okay. Then I can go with interquartile range. I can interquartile range, and I can go with interdecile range. I can also go with something like variance, standard deviation, mean absolute deviation, and so on. So there are multiple ways of calculating range. So let's kind of go into it in a more detailed manner. Okay, by the way, I would be stopping at 8 because I have to kind of get to office early. We will cover this on Friday. All right. Any last time we would be covering it over on Friday. All right. So properties of mean and median, measure of central tendency. For symmetric distributions, mean is equal to median. So if I have a symmetric distribution like this, then mean and median are the same. However, if I have a distribution kind of like this, then this probably would be median because this is the center value. There are less frequent values, and this probably would be the mean. So the median would be slightly closer. If the distributions, for example, is kind of like this, then this becomes the median and this becomes the mean. So and so forth. So for symmetric distribution, mean is equal to median. For skewed distribution, mean and median are usually different, but it also is necessary to understand what is the difference between median and mean. So sometimes the actual average is more important to us. Sometimes the position of the middle value is more important to us. Can somebody give me an example where median is better? Can somebody give me an example where medians give us a better understanding of the data than than the mean?
When the data is skewed, I think
Give me an example, actual example. So one of the things is all of these colleges, right? Your IITs and IIMs, they give you average salaries. That is often misleading. Which is often misleading. So a lot of places we want to know what is the median salary, which means what is the middle person getting as a salary. That gives us a better idea. If you are average in the class, okay, which means half the people have better scores than you or better placements than you, half the people are, having lesser placements than you, then what is your pay? That is a better indicator of what the actual pay is. So while the average could look like 40 lakhs, the median pay would be like 10 lakhs, which is more realistic. So I want to know that. Right? So for example, being the topper of a class and completely blowing everything away, that may not be possible for everybody, right? Sure, there is one guy in IIT who is getting a 2 crore ka package, but there are also a whole bunch of people who never got placed. They did not get placed in the entire week. It took them several months after which they could get a job. Right? So it is not giving me the perfect. It is not giving me a good understanding of how the placements have happened. They are showing me one outlier and they are making me think that everybody else is doing the same way. They are not. Right? Yes or no? So let's say if I'm average, if I'm in the middle of the class, I'm not even in the top 10 or anything. If I'm in the middle of the class, what is it that I can expect? Because that is something that I can manage. Right? I can manage to not be in the bottom 10. I cannot guarantee that I will be first in the class. because that can be very difficult or different or anything, right? I don't know where that person who is the topper of the class even coming from. He could be coming from a very elite family. He could be just one of those geniuses. I cannot compete with that, right? But I can make sure that I am, at least in the middle of the class or slightly above average in the class. Yes or no? So the thing is, median gives us a better insight sometimes when it comes to these things. So, for example, if I'm trying to understand the average salaries of the people in the country, one Ambani is enough for taking away the salaries of more than, let's say, 10 crore people. Yes or no? His salary is, I think, like 15 crores or something right now. How many people make 15 crores? Yes or no?
Yes.
So very few people actually do that. So most of the salaries, let's say in India, are about 20K. Okay. So the average, so the per capita income kind of comes down to about 4 lakhs. But that is also little, 4 lakhs or 6 lakhs. I think 6 lakhs is the average per capita income. But that is also misleading because it is taking into consideration people who are not yet working, and a lot of women who stay at home, older people, all of that. So it comes down to 6 lakhs per annum per capita for everybody. So that is the average. But the median would be able to give us a much better idea of what the salaries in India are like. Right? So that is where we are. So median and mean have different applications. We often go with mean because we kind of assume a uniform distribution for our data sets. For that, we need to understand what are outliers. We'll come to it on a later date. How to identify an outlier, what qualifies as an outlier, and if we can remove the outliers, then we can always go with the mean. But for some reason, we have kind of come to a point where we kind of understand averages better than we understand medians. Please understand. Also, as humans, we do not quite get the concept of averages or medians at all. Statistical thinking is very difficult for humans. We all pretend to understand. For example, if I ask you to exactly explain what is the point of a mean, you will not be able to explain it to me, in a very convincing manner. Think about it. The average actually makes no sense, right? But we're using it on pretty much everyday basis. If I ask you to exactly explain it to me, you will not be able to explain it to me because our minds are not just built for statistical understanding. However, we have kind of come to a point where we are using it in our everyday language. He's an above average guy, he's an average player, right? The food is very average over here. We do that constantly, don't we? Yes? Yes, no?
Yes, sir.
Yeah. So that is where I will stop this thing. I want you to kind of think about this thing. When we meet on Friday, we will start off with various types of measures of dispersion, and how to mathematically start writing these things. Okay. Then we'll also take up a couple of Excel sheets and we'll start calculating these things. We'll and go through the basic formulae within Excel and all of that. We'll try to finish this on Friday. Any questions? Any questions?
Can you say always that average median value will be less than the average value?
There is no such thing. So, for example, I showed you, right? And if my distribution looks like this, right? This is the highest value, this is the lowest value. My median will be somewhere over here. Median is also usually the highest frequency value that you get. The mean would be somewhere over here. This would be median, and this would be mean. On the other hand, if my distribution kind of looks like this is the highest value, this is the lowest value. The median would be somewhere over here, mean will be somewhere over here. So sometimes median can be higher, sometimes mean can be higher. Depends upon the distribution. Make sense?
Yes, sir.
So imagine a class wherein the top 10 have decided to all go into quantitative trading and they all got 1 crore packages. Then rest everybody else, they were not into it, and only a few people were left behind. Right? So that also can happen. Right? So the point is, when we put up a distribution of the data, you kind of get an insight. You start to see that there is something going on in that piece of data, and you can ask more questions rather than when it was in a simple table as numbers. So when we convert that, it usually kind of gives us a better understanding of the numbers. Okay, chalo, I got to get going now. I will see you.
Thank you, sir.
All right, see you.
Thank you, sir.
Thank you.
Thank you.
Thank you.